Hello guys, in today's video we are going to see one theorem and followed by example, and also this theorem is very important. You'll get direct question from this, like they can ask you directly like prove this theorem, and then they'll give one example as a question and ask you to solve that question. Or if not, they will give you this theorem example, this concept example as a 3 marks or 2 marks question and ask you to find the matrices. Okay, it can be asked in any way. And now we'll see the theorem first. So every square matrix can be expressed uniquely as a sum of symmetric and skew symmetric matrices. So what is this theorem is, if you take any matrix, okay, any matrix, so the theorem what it is stating is, if you take any matrix, that matrix you can express it in the sum of two matrices, okay, two different matrices. And that is first condition in this, first statement you can say. Okay, what is the first thing? We can express a matrix in the form of two matrices sum. That means if you take a matrix, you can express the A matrix as a sum of two matrices. Let's take A1 and A2 as the two matrices. Okay, that is first one. Now the second one is, they are saying sum of symmetric and skew symmetric. That means here one matrix should be symmetric and the other one is skew symmetric. This is the theorem. Okay, we have to prove this one. Alright, now let's see how to prove. So in mathematical theorems, first we will make assumptions first, right? All the assumptions will be taken, and then from them we will lead it to the conclusion. Okay, first let's take a matrix. So let A be a square matrix. Okay, this is what we have to prove. Now how I can express this A matrix? I'll take A plus A by into 1 by 2, right? See, if you solve this, 1 by 2, A plus A is 2A, cancel 2, A into 1 is A again, so A equal to A, right? So we can express A in this way, right? Now I want to add A transpose for this and subtract it so that the value will not be changed. Why I am taking A transpose here? Because we know that symmetric matrix means what? A transpose equal to A. Then what is skew symmetric? A transpose equal to minus A. So if A transpose equal to A and A transpose equal to minus A, then we say that these two matrices are skew symmetric and symmetric, right? So for both matrices, for both symmetric and skew, we need A transpose, so I'll add A transpose here. Okay, see, this is how you prove theorems. You'll have only the statement. You have to make all the assumptions, you have to take all the values, and then you have to subtract. So whatever you do, the value should not be changed. Okay, now I'll take half of A plus, I'm adding A transpose. So I added A transpose, so I have to subtract it, right? Only then the value will not be changed. So we have one more A and then minus A transpose. Now if you solve this, plus A transpose minus A transpose will be cancelled. Again A plus A, 2A, A 2 will be cancelled, again A. So whatever the matrix we have taken, it will be same. Adding all those things also will not give us a different result, right? Now what I'll do is take half and write it in separate, because we have to express at sum, right? We have to get one matrix here and then one, both should be separated by the plus, right? So I'll take A plus A transpose once, half A minus A transpose. So this can be written in this way, right? If you again solve this, half A plus half A transpose plus half A minus half A transpose. Again if you take half common, you will get the same thing. Alright, so we can write. Now if we see the statement here, this is one matrix let's say P. This is other matrix, we'll say as Q. If you observe the statement, we have proved the first statement, right? A matrix can be expressed as the sum of two matrices. We have expressed it, right? We'll take P as one matrix, Q as one matrix. So we are done with the first part. Now we have to make sure that these P, Q and matrices are symmetric and skew symmetric as per the theorem. Now what we will do, first let's prove the symmetric part and skew symmetric part. Now we have P, we have Q, right? What is symmetric? A transpose equal to A. Okay, we are solving for the P part. That means we have to show that P transpose equal to P. Then we can say that P is symmetric, right? So we'll prove that first one. Okay, now I am considering P transpose. So that means 1 by 2 A plus A transpose whole transpose, because we are finding P transpose now. Now what I'll take this 1 by 2 outside. Now A plus A transpose whole transpose. Okay, in the previous video I have discussed the properties. Okay, I also told you that you have to know these properties and you have to remember those properties because you will be using in the problems. So here we'll use those. So A plus B whole transpose. Then we can write A transpose plus B transpose. 1 by 2 A transpose plus B transpose. Already we have B as this one, so whole transpose you will get. Now again we have one more property here. A transpose is A transpose. A transpose whole transpose. Transpose will be cancelled, so you will remain with A again. This is also one property. Please have a look at those properties. Okay, only then you can solve this type of questions. Now what we got? Again P value, right? Whatever the P value, half A plus A transpose, half A plus A transpose. Hence it is P. So P transpose equal to P. Hence this P matrix is a symmetric matrix. Right? We got this one. Now let's prove Q. Okay? For skew symmetric, we are saying that Q is skew symmetric. That means Q transpose should be minus Q. If we get this condition, then this is satisfied. Am I right? Now let's take Q transpose. That means half of A minus A transpose. Okay, this is Q, right? I took this one. Now whole transpose, same as like we did for P. Now again take the 1 by 2 outside, right? A transpose minus A transpose whole transpose. Now half of A transpose minus A. Okay. Now what I'll do is I'll take minus outside. I'll take it as a common. So minus 1 by 2. So what you will get if you take common? Minus A transpose plus A. Because when you multiply minus into minus plus, so plus A transpose we got. Minus into plus is minus A. Okay, you have to make sure whatever the operation you do, value should not change. Now what happens? Keep this minus. If you observe this part, this is Q, right? Half of A minus A transpose. Okay, this part. So this is as Q, right? Half of A minus A transpose, and here also we have half of A minus A transpose. We can write minus A transpose. This will be clear. So minus, let it be. This is Q, right? So write it as Q. Now what we showed? Q transpose equal to minus Q. Hence Q is skew symmetric. So this is how you have to prove a theorem. Okay, you have to take all the assumptions. See, in this theorem they only give the statement, right? We derived all these things. So this derivation is very important. And now let's see sum. Okay, so I have written question here. We'll just see how to solve this. And now here they gave A matrix. Okay, just compare here. They gave this A matrix. We have to find the P and Q matrices for this sum, for this matrix. Okay, now according to theorem, right, according to theorem, P is what? Half of A plus A transpose. Then what is Q? Half of A minus A transpose. Then if we directly substitute A and A transpose in this values, we'll get the P and Q matrices, right? That is what we have to find according to the question. So how we got this P and Q? Because of the theorem. That is why I have explained you the theorem and then followed by the example. In exam you might get the question for theorem or not. They only ask you this P and Q matrices. In such cases, then you will wonder how to solve those symmetric, how to get those Q symmetric matrices. Since we know the theorem, we can easily solve these questions. So now I'll first find A transpose, because in both we have A transpose common. So let's write that quickly. So A transpose means rows and columns are interchanged. Take first row, write it as first column. Take second row, write it as second column. Take third row, write it as third column. Okay, I wrote it. Now what I'll do, I'll simply find this A plus A transpose and then A minus A, then I'll divide it with by 2, you'll get P and Q. Okay, now I'm doing first A plus A transpose. So what is A? They already gave in the question. 2 minus 4, 9, 14, 7, 13, 9, 5, 11. Add it with A transpose. What is A transpose here? This one. 2, 14, 9, minus 4, 7, 5, 9, 13, 11. Add these two matrices. How you will add? The same position elements. 2 plus 2 is 4. Minus 4 plus 14 is 10. 9 plus 9, 18. 14 minus 4, I mean plus of minus is minus, right? 14 minus 4 is again 10. 7 plus 7, 14. 13 plus 5, 18. 9 plus 9, 18. 5 plus 13, 18. 11 plus 11, 22. Okay. So we have written A plus A transpose. Now what we have to find? We have to find the P. What is P? P is half of A plus A transpose. So I'll write here P is equal to half of A plus A transpose. So we have already got the value of A plus A transpose from here, right? So half of what is A plus A transpose? This matrix. 4, 10, 18, 10, 14, 18, 18, 18, 22. Now by 2, right? That means we have to divide every element with 2. So 4 divided by 2 is 2. 2 5s are 10, 2 9s are, 2 5s are, 2 7s are, 9s are, 9, 9, 11. So this is what the matrix. So this is, you can say, P matrix. We have find the symmetric matrix. Now let's solve the same procedure for the skew symmetric matrix also. Okay, we'll see that now. So we have to find Q, right? Q is half of A minus A transpose. Let's find A minus A transpose first. What is A matrix according they gave in the question, right? So here it is. Okay, 2 minus 4, 9, 14, 7, 13, 9, 5, 11, minus we have got A transpose. We already found A transpose in the starting, right? So I'll write this matrix here. 2, 14, 9, minus 4, 7, 5, 9, 13, 11. Okay, we already found A transpose when doing for P. So A transpose will not change, right? So I have written the same thing. And now let's solve this one. So you have to subtract 2 minus 2 is 0, minus 4 minus 14, minus 18, 9 minus 9 0, 14 minus into minus plus. So 14 plus 4 is 18 again, 7 minus 7 0, 13 minus 5. 9 minus 9 0, 5 and minus 13 is minus 8, 11 minus 11 0. So we got A minus A transpose, and now quickly we do it for half. So what is Q? Half of A minus A transpose. So half of what is A minus A transpose? We have got here 0 minus 18 0, 18 0, 8 0, minus 8 0. Now let's do it half. 0 by 2 is 0, minus 9 0, 9 0, 4 0, minus 4 0. So this is Q matrix. Okay, this is the solution. Okay, you have to write, hence P is whatever the matrix we got, and whatever the Q matrix, you have to write P and Q. These are symmetric and skew symmetric. But in the exam we all will have doubt whether our solution is right or wrong. So in such cases I'll tell you quickly verification, how you have to verify. Please don't write this in the exam. When they ask you to find the symmetric and skew symmetric, this is just to know whether your solution is correct or not. Okay, so what we got, what is the P matrix we got in the previous video, sorry, not previous video, in the previous step. This one, right? 2 5 9 5 7 9 9 9 11, right? What is the Q matrix? 0 minus 9 0, 9 0 4, 0 minus 4 0. Here we got Q, right? So I wrote. See, we in this example they asked us to find the symmetric and skew symmetric, and we got that according to the theorem formula. We took this P and Q. If you observe here, we have one more statement. I told you, right? First statement is what? Every matrix can be expressed as sum of two matrices, and that sum of two matrices are what? Symmetric and skew symmetric. Now we have symmetric and skew symmetric, right? So if we add this symmetric and skew symmetric which are obtained, you should get the A. That means A means what? Whatever the question they gave. So if we add this P plus Q, you will get one matrix, right? So that matrix should be as question. That means A matrix. So this is how you will verify. That is why the theorems are very important. They'll have number of statements to prove and number of statements to understand, wherein you can use the answer, whatever the answer you got for the verification also. Quickly add this to 2 plus 0 is 2, 5 minus 9 is minus 4, 9 plus 0 is 9, 5 plus 9 is 13, 7 plus 0 is 7, 9 plus 4 is 13, 9 plus 4 is 13, 9 plus 5 is 14, 9 plus 0 is 9 again, 9 minus 4 is 5, 11 plus 0 is 11. So this is P plus Q, right? Every matrix can be expressed as a sum of two matrices, and then we expressed it. So if the two matrices are symmetric and skew symmetric, their sum should be same as question. So let's quickly check whether we got the answer correctly or not. So if you see, I will keep side by side. 2 minus 4 9, 14 7, 14 7 13, 14 7 13, 9 5 11, 9 5 11. So this is how you will verify. So we got the question, that means A matrix and our symmetric and skew symmetric matrices are correct, because we got the result. We have expressed them as a sum and then we find out the result. This is how you have to verify your answer also. Okay, thank you.